Hey everybody, this is Larry. This is me doing the weekly premium problem. 11.99 minimum time to build blocks. A problem that seems like I haven't seen that before. So let's get to it. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. You're given a list of blocks where blocks of I is 0 to t, means that the ith block requires t units of time to be built. A block can only be built by exactly one worker. A worker can either split into two workers or build a block and then go home. Both decisions cost some time. Okay. Still, to be honest, not understanding this, but maybe my brain is just a little bit slow. The time cost of splitting one worker into two workers is given in just split. Note that if two workers split at the same time, they split in parallel, so the cost would be split. Okay, so we are given that as an input. I'll put the minimum number of time to build all blocks. Initially, there are only one worker. Man, what does that mean by splitting? Okay, let's see. Let's take a look at some examples because I'm not really sure. Okay, so let's say you have a block of one. You have one. It costs one to split. So okay, we can split in 5 units, and then you assign them so that block. Okay, I see. A block can only be used as one worker. Okay. N is equal to 1,000. That's what I needed. I think I was thinking of whether to do dynamic programming. I'm not sure actually. Now that I think about it, because I think one thing that I initially thought was whether it's splitting, but because you could split at the same time and you want to split at the same time, then or if you are able to split, you want to split at the same time, in theory, right? Like in this case, I guess not, but So I'm thinking about right now, just thinking about how to do dynamic programming. I think that it's probably still a dynamic programming. I think one thing to note. That's not true, is it? I think maybe there's a binary search thing, I want to say. Because, unless I'm misunderstanding this, hang on. Yeah, okay. Actually, no, I think that's right. But it's just that my math was a little bit wrong. Yeah, in this case, because you can basically the idea and example 3 is a good illustration of this, is that if you start someone on working on something as early as they can on the more expensive stuff, then you can split a little bit later. You could keep on splitting and then do it. I think that in that way it makes sense to have a binary search, but but I'm not convinced quite. I think that makes sense. Now, whether I can simulate this in a good way, I'm thinking of right now. I think at the very least, the thing that we should, unless it is already given in sorted order, we should sort it just to kind of give this a little bit of a structure, the input in a little bit of structure, and because my initial hypothesis, and I don't think this is right anymore, now that I read the problem maybe slightly more correctly, is that you always want to do all the splitting at the same time. I don't think that's necessarily true, because if you have something like, I don't know, something like 1,000,000 or something, this is not 1,000,000, but it's a big enough number. Something like this, or maybe even structured a little bit smaller, right? And let's just say split is equal to 1, right? Then in that case, you actually want to do them all at different times, because then first you split into 2 people, right? And then now you take one and put it on the 10,000, and then you split the other one into two, right? And then you split the other one into two, and then work on the 99,999, and then the answer dot dot dot. But the answer is going to be, 10,001 or whatever it is, instead of, you split them all at the same time. You save time on the splitting, like you branch out as early as possible, but that actually gives you a wrong or a longer answer, because now like you take 3 steps to get to 10,000, and then you start, so it'll be 10,003 or something like this, right? So okay, so I think that's why I think binary search kind of makes sense. But I don't know how to do it necessarily, to be honest. Like in this, even for this input, how do I binary search? Right, because the thing is that you can, and let me double. Yeah, I mean, it could be, everything can be done in parallel. Can I do DP? Split is only 100. Does that change things? Like I still have, like, it feels very binary searchable, and I think it is binary searchable, but, or at least like you can binary search for the answer, and let's say you have a magical function that determines whether you can or cannot, then that's what you would do. But I don't know that the magical function, or I don't know that I know how to write the magical function in a way. Let's see, right? How do you write the magical function? Maybe you can. Maybe I'm just being a little bit lazy, because yeah, maybe that's the way to go. Maybe I just need to be not lazy. Maybe I think the way that I thought about it is the way to do it, which is just greedy, and then do the math that way. I think the way to do it is for each one, yeah, just kind of do it as most as possible. Right, so yeah, I think it's just simulation, and then kind of keep on doing it, and then see if it's possible. Okay, yeah, I mean, I think maybe I made too much of a deal on this part, but I was just kind of wanting to sanitize myself as well. So what is the longest time? It's going to be 10 to the 5th plus, let's say 1,000, right? So 10, let's just say 10 to the 6th, right? That should be good enough. Right. So then if we can accomplish this, what does that mean? If we can accomplish this, that means that we can try a smaller number. So we said right is equal to mid, left is equal to mid plus 1. We have to try a bigger number, and then we just return left. Yeah, and then now we have to write the magical function of good. And I think the time we have, okay, I mean, this is going to be, let me actually put this in the input, so then I can, if I know how to do this correctly. Right. I just return true, just so I can make sure that I didn't, wouldn't have a typo here. Okay, right. Yeah, and if you do agree, it'll be 10. I mean, okay, so then now we just have to simulate, right? So it is 10 to the 5th. What does that mean? So okay. So let's say we start with one worker, right? And then for I don't know, block in blocks. Let's call it X. For X in blocks, what does this mean? Basically, now it means we have delta time. So how much time do we have to get started, right? What does that mean? Well, that means that let's say we have to finish in T time. T time? I feel like I'm sounding like I'm British, you know, get some tea time going on. But no, okay, so it's T minus X. That's the number of time, right? And I guess you can write this in a number of ways, I suppose. But, like, you can write a for loop, but no, that's fine. But basically, current is equal to min of current. Basically, we're now splitting delta number of times, so it's going to be 2 to the delta. But this can definitely maxed out. So let's just say there's at most 1,000 blocks, so you at most want to split 10 times because, well, then you just get through all the blocks anyway. So that we can do maybe like a min of delta, and I just say it's conservatively 12, right? Okay. We also want to add a thing where if t is less than x, then we return false. Otherwise, we calculate the delta current. This is the number of things we split. Oops, and then we use it on the current person. Yeah. If current is greater than 0, that's good. Oops. So I guess if it's less than or equal to 0, then we return false. And then otherwise, we just keep looping and keep multiplying our people. Okay, so we'll see if I just returning big numbers on all of them. Why is that? Did I mess up the loop? So if we ran out of workers, so that means we cannot finish in time. If we cannot finish in time, that means we need more time, right? So if this is false, we need... Oh, I got this wrong, huh? I just kind of... If this is good... If we can finish in t time, then we try to do it faster, right? Why is this wrong? Wait a sec. This should be right. Or, well, I mean, clearly it's not, so... So if we can finish in mid-time, we want to finish in a smaller time. Otherwise, we try a bigger time. That makes sense. Did I screw up something? Oh, this is a little bit weird. It's not t. Well, I mean, it still should not be. I mean, it may be wrong, but it's not. It shouldn't be wrong the way that we have it. That part's a little bit weird. I did actually thought about this, but I just forgot. But this should have been. Also, this is wrong. This is current times this. Maybe that's why, actually. I mean, I'm just gonna... It's... Because I was thinking current is equal to 1 to kind of kick it off. That's why that's wrong. But yeah, that's the number of times you multiply. This should give us a more optimistic answer if we're correct. But this is still wrong because it's giving like, what is it? Whatever, 100,000, right? So that means that it's wrong in the wrong direction. Because it's basically because it's saying that we keep on needing more time. Oh, this min current is wrong because that's why. I think I just confused myself. Why did I need min again? Okay, now we're good. I mean, we're not right yet. We're not of the width, because this is still wrong, but that's fine. Because this is wrong in the right direction because I didn't update t. Because now t should be the last block, right? So because basically this is the delta time that happened. So maybe we could do like last t is equal to actually just t, right? And then now last t is equal to x, because no, is it equal to x? Basically it yeah, it's equal to x. It's the way that I wrote it is a little bit awkward actually, but oh, I mean I still have to use it. That's why it's not working. Still wrong. Did I mess up something still? Oh, the split cost. That's why. I actually didn't use split cost at all. So okay, that makes sense. Okay, I mean that's simple. Yeah, that's simple. Okay, I just forgot about it. I feel like I've been forgetting a lot of things lately, even if I don't necessarily eat up a wrong answer straight up. All right, am I good? I think I'm okay. So let's give it a submit. I mean, it got case 4, which is the one that I created. Oh no! So my output is that it's longer than this, which is am I getting an off by 1 or something? Oh, I see. I see. That is tricky. Okay, we have 10. Yeah, I got a little bit lazy on putting down the split. I think that's why. The reason is because you cannot actually just do it like this. Oh, that's trickier now. I have to think about it. Because basically, I think one of the assumptions on how I wrote this was because, for some reason, and I just forgot about it to be honest, is that I was thinking that split is equal to 1 always, and when split is equal to 1, then you can always, there is a sort of greedy in how I structure it, in that I always greedily want to split it as early as I can, right? Because it only costs 1, so by the time you get to the next one, you'll always be a little bit better, right? And that's what. And then I just kind of hacked it together afterwards by splitting divided by split. But this doesn't really work necessarily, because for split 9 equals to 1, then basically the short answer is that there is a little bit of a leftover. And I have to think whether you always want to split as early as possible, right? Because I don't think that's true anymore. Is my point. Do I have this? Let me actually put in the case. Okay, I don't think that's true anymore, because before you always split because there's nothing, otherwise the workers are just standing there doing nothing. But conceptually, you could imagine that a worker, instead of splitting, may wait, say, 2 minutes or 2 time unit to start to work on the next thing, instead of just splitting for no reason, right? Because maybe it takes 5 seconds to split, so maybe you work, or you do nothing, and doing nothing is a more optimal solution, right? Oh, wow. I have to give it some thought then. I think that was why I kind of convinced myself that maybe binary, or the magic function of the binary search, may not work. But now I have to kind of, and I forgot about it somehow. I think I just kind of looked at some examples and then, man, my memory is just shot. Okay, so now how do I get around that then, right? Let's say it takes 5 seconds to split. And you have a job in 2 seconds. Is it DP? Now is it DP? Let's see. I mean, you know that you need at least N workers. Wow, this is a hard one. Man, I really messed this up, didn't I? Oh, whoops. Spread is only 100 as well. Is that something we can exploit? At most, you want to split 10 times, so that means it's going to be like 100 times 10. In theory, maybe not. Maybe it's the thing that we said earlier with 1 at a time. And we can construct a 1 at a time case, but that's just going to be 100,000 plus 1,000. So that's not bad. Oh, 100,000 plus, I don't know, 100,000, 200,000 is good too. Man, wow. Can I think about this backwards? Right? Meaning, here, the way that we did is just by simulation upwards. But can we look at it backwards and be like, okay, let's say we have X and we're trying to find T. That means that the latest that we can get a worker that starts here, it's going to be, I don't know, right? Like, yeah, T minus X minus split, right? Something like this. And let's say you have a and let's say you have an array of that kind of thing that you need, except for the first element, I suppose. But can you, and then now is it just becoming, can you do a DP on that? Maybe. I mean, I think I could do it that way. Let me think about it for a second. There is a naive n squared dp, but then now it becomes n squared log n or log m or whatever, and that is definitely too slow. Basically. Yeah, that is definitely too slow. I don't know that I can do it much quicker than that. Then you just simulate doing them all at the same time, and then that's a little bit tricky. What is the DP? Can I write the DP in another way? So we start with one thing. And then you split. How would that split even look like? That means that at unit split you would have, the first one's easy, and then you have to choose how many to split. That's trickier, isn't it? Because then now that's where it becomes n squared. Can I just do dp in that way then? You start with 1. I guess maybe there's an n square and without the binary search. Let me think about it a little bit. Otherwise, let's see, right? Let's call calc build time, and then basically you have blocks left, so that's index, and let's define a function. So now you have the index, and then maybe let's say maybe the number of workers. I think the number of workers is fine. And this is n square already. Right. Maybe I still did need to do it anyways. Because you always want to assign workers in reverse order anyway. Okay, so then now here, if workers is equal to 0, we return infinity. Yeah. Because, oh well. If index is equal to n, then we return 0 because our job is done. If workers is equal to 0, then we return infinity because we have no more workers and we have jobs left. Otherwise, for this current job, we either assign a worker to it, or we don't and we just split. Because you always want to, okay, in that way that makes sense. Okay, so then now, let's say we assign worker, right? That means that we have calculate build time of index plus 1, workers minus 1, and then so that's the rest of the min time. So we'll have to take the max of this, oops, and block sub index, and then the split worker, and we can split as well. This would be splitting the worker to figure out the current person. So it would be max of calc build time. So the same index, but workers times 2. We want to say max it at n. Oh, sorry, minute at n. Yeah. Oh, I guess that's just it. We don't care about the block. We just recalculate it again. But there's a thing to prevent it from going to infinity, I think. And I just call it min n plus 1 then, right? And then if workers is equal to it's actually not n plus 1 per se, is the number of leftovers. So it's something like n minus index or something plus 1, say. But I kind of want to keep it simple, dumb for now. Yeah, anyway, and in this case, actually, it's something like this. So maybe we don't need this then, because by definition, this would be a greater number left. I have to make sure I'm off by better about off by 1, but then it just becomes max of blocks sub index. This is O of n. We have to be careful, but for now, I'm worried about correctness and not the timeout. So please remember to fix it. No, I'm talking to myself. Reminder or fix me, I guess it's a okay. Yeah, and then now we return the min of assigned worker or split workers. Because if we split, we should do them at the same time anyway. All right. I know that I usually do the whole thing about caching, but I'm just going to use cache for now. Because I'm still trying to understand the harder part of the problem. Oh, oops. Oh, I don't think I did this. Okay, so this takes split costs. Yeah, oops. Huh. I mean, we have to make a couple of optimizations here, but it seems like I think I just didn't really think about. I think I was just too stuck on it on the binary search. I mean, this seems like the case 5 seems like a good example enough for me to say this is probably the answer, and I kind of, today just kind of struggled a little bit about it. Don't know why. We should do this fix me, and you can do this by caching. Yeah. The reason why, so this is one of those problems that actually cache is a little bit. I mean, we can actually just put this back here. The reason why I say that this caching is a little bit tricky is because workers times 2 can actually have a range of solutions, right? Meaning, like, let's say workers is 5, then workers 5 times 2 could be 10, but and if workers is 6, then it could be 12, and then you have like 10, 12, 14, 16, or whatever. But let's say n minus index is 1, just for example, then all of them should collapse into one memory caching unit, but it doesn't because just because, well, the inputs are different, right? So that's one thing that you have to be a little bit careful about, but I think we're okay here. So we can fix that quickly. We can yeah, I mean we can fix it quickly, but we have to also do the fix me. So let's do the fix me first. So then that's just suffix max, right? So suffix is equal to say it for I in range of. Oh, I'm silly. This doesn't even. We sorted in reverse order, so this is actually just box of index. Right, so that already solves some. So we don't even have to. I just didn't. Well, I didn't want to spend time thinking about it because I want to make sure that I spend time thinking about the rest. And then here, You could collapse it by using if statements and then collapsing it that way, but you can also collapse it by just collapsing this as maybe something like needed is equal to n minus index, and I'm still worried about off by 1, to be honest. I should think about this. N minus, so if index is equal to n, then we need 0, otherwise it's equal to 1. I guess that makes sense. I think this is good actually. But yeah, needed is equal to n minus index. So then now we can do a min of this needed. So then this will always at worst collapse to as a function of index, which kind of perform this in the caching part. Okay. So what's the timing here? 182. So that looks okay. Let's give it a quick submit. I think I just kind of, I mean, it may still be wrong, or it may be that Leetcode is a little bit slow on this. So we might have to use that trick anyway, because cache is a little bit slow for n square stuff for whatever reason, because Leetcode. But this is like a very Leetcode specific thing, to be honest, because I think this, if I wrote the same thing in C++, this would be good. Put it that way. Yeah, I guess in this case it'll be just n squared literally. We'll see if this is fast enough. If not, then I mean, at this point, I think this is easy to. I don't know if it's easy, but it is doable to write in bottoms up. I really did get this fuse. Man, I mean, I'm just out of practice, I guess. Because this really feels like a binary search problem, to be honest. And I think that's how I got, suckered in a little bit. But, I mean, that's fine. It's part of learning. But it used to be that DP was one of my strengths, but not so much anymore. 873, I cannot see memory usage, but looks okay. We'll see if this is good. I mean, it might not, or it might not be for Leetcode reasons. Can we? They should make it so that we could guide it once. It's fine. This is pretty long and big though. I mean, we can definitely optimize this a little bit. I think and another thing that you can do is space optimization, which, given this, maybe we should do. Let me do the. I mean. And maybe today you're in for a treat because I don't do this very often on video, but I'm going to try to rewrite this as bottoms up. Yeah, and then we'll take a look. And then you could do the space optimization thing, which I guess I'll show you. I'll do it without the space optimization to begin with, just to kind of, I don't know, just to start it off. Right, and then now for index is equal in range from I guess 0 all the way to n. Yeah, n's fine. And then now for I guess work. Oh no, work is in range of n is fine too. Is it n or n plus 1? Well, the way that I wrote it is a little bit awkward for sure. And n cannot be, I think n plus 1. Is it? Well, the reason why we didn't need n plus 1 here is because we stored it implicitly in that, so I think we do need it. And we're gonna, okay. Watch me lie, then this is not as easy as I hope it would be. But yeah, so this is equal to this is a little bit tricky actually, but because then now we have to do it backwards. Fine. Yeah. Is this backwards? Yeah, okay. I think that's right. Is that true? Yeah, I think that's fine. And the thing with bottoms up is that some of these dates are not possible, but for the purpose of this, I guess we'll just kind of keep at it. Let's rewrite this a little bit so that I can have so I don't have to do as many if statements. You could have used this as an if statement, like translating these into, but I think it's fine. And here we don't go to 0. We just go. Yeah. We don't have to go to 0. So we set this Leetcode to 0. Yeah, because we're done. Right. And then now we can just do, the copy and paste thing, right? This is gonna be so the box of index, so max of this, and then also maybe min of this. The other thing, which is dp of index, but workers times 2, right? And you can see how the way that I write it, and maybe whatever, but is way copy and pasty, right? Like yeah. So hopefully it doesn't look too intimidating. Nope. Plus split. Okay. Don't forget about split this time. And that's pretty much the idea. And then we can just return dp of 0, 1, and should be good. I mean, it might not be good because I am way prone to making silly typos, but and maybe I have one here. Oh, index doesn't. No, this makes okay sense. What was error again? Something's outbound. This assignment index plus 1's okay. Workers goes to 1, so that should be okay. Index plus 1 goes to n. Yeah, I mean, it should be okay. What am I missing? Okay. Maybe I just have something silly. Like 1 and 3 for which file? For Q1. What? Yeah, that did not. That raised more question than it. I don't know what that means. So let's get a little bit. Okay, so it's for this problem. Okay, that's. Oh, I guess this one we just return directly. That's why I was a little confused. Okay, so 2, 1. So for 3 workers, why do I have 3 workers? Oh, this is n plus 1. Whoops. Do I need n plus 1? We want to assign it. Is it n or n plus 1? No, it's just n. You need n workers for n people, or n jobs. I don't know why we wrote like that. Okay, I'll put it. I mean, that's fine. I knew that was going to be a lot of output. All right. Looks good. Let's give it a submit. And we could do a space optimization afterwards. There are a couple of ways you can think about space optimization, and we'll go over it. This may time out. That'll be funny. The reason why this may time out and not the other, it's a little bit slower actually, but you can see the memory usage is much better because, yeah. The reason why this is slower is because we're doing steps that are not necessary. I think maybe we could do something like if I think the reason why we didn't this is slower actually isn't just that. It's that we look at this code. I actually did not have. You could consider this an optimization because now it doesn't have to split for some of these things. So because I kind of didn't have this part, I need to do a little bit better. Well, I need to put it in, if you will. So let's think about it. Workers, if workers is greater than or equal to n minus index or something, then dp of index workers is equal to what is that equal to? Box of index, right? As we said. This already looks a little bit faster. Let's give it a submit. Yeah, see now you can see that it's shaved a little bit. So definitely, even though the other one is technically correct, now you removed a lot of states, and you can still do a little bit better because a lot of states are not actually reachable in the recursive way. But at least now, you can see that it is much faster. And actually, at this memory, I don't even have to do the memory optimization, but we can do it. We can do it. What can we do? Oh yeah. I mean, this is a easy space optimization. Basically, there are a couple of ways you can write this, but yeah. But basically, just how do I want to write this? Yeah, let's just write it this way, right? And that's really all you need. And then now it only looks at use two things. So yeah, I think the only thing you have to do is do the update. This part is a little bit tricky, but not tricky. Just like takes time. I think it's all. Actually, you don't even need to. I was gonna say you could reset it, but I think this actually just assigns, so it doesn't. I don't think maybe that's needed. We haven't done the actual optimization yet, but I'm gonna just run it real quick. Did I make a mistake somewhere? Oh, this part I forgot to do this. Yeah, so this looks good. The time is a little bit slower. Is it? I don't know. But now you can reduce this to 2, and we'll just. Right. Did I make? Maybe my base case is a little bit wrong. Oh. I think the base case is a little bit. No, n minus 1 should be fine. In doing this. What am I missing? Usually that's enough, to be honest. But. Unless I missed a spot anyway. Oh, this is not true any. Is that still? No, that's still true. I think that's still 0. Huh, where did I mess up? But in theory, that's all you need. But apparently, you actually also need a little bit more. But why am I am I just returning the wrong thing? Start at 0, so yeah, I mean that should be fine. I think this part is the tricky part. I think my base case is a little bit weird. I think it worked in the other case, but it may be that. No, I mean this part should assign it. So because I think one thing that you can do. Let me just rewrite this a little bit, right? Because I think this part is a little bit tricky when it goes to workers times 2. I think that should be okay. We write it. We looped in the right order. But okay, fine. Let's take a look real quick to see if this solves it. But basically, the thing with the space optimization often is that you have to make sure you don't use the memory, or like use memory that is what you think it is when you use it. Which, it's very easy to make a mistake. And you can see that I'm making mistakes, apparently. I think this is just flat out wrong. Apparently I'm not. Why did we need this then? N plus, if it is n minus 1. I don't know if this, wait, am I just lucky? I don't think that this makes sense. Oh, I think this actually end up being the base case because, yeah, by definition, it skips this. So then now it doesn't do because the way that I wrote it originally, then I needed this. But because of this optimization, I actually don't need this anymore. And in fact, that led to wrong things for some of them, I guess. Okay. These things are tricky. All right, let's give a spin. Hopefully I don't get a wrong answer. This may actually end up taking longer. Yeah, but you obviously that's the trade-off for memory, right? I mean, maybe not. Maybe I just kind of wrote it in a stupid way. I don't think you actually need to. The way I wrote it is for sure. Because now. And you don't allocate that much. I mean, you definitely save on the memory, but the way that I wrote it is kind of dumb, to be honest. Wait, how do I go back? Because now this is index mod 2, and we do a lot of mods. And now we do 5 mods, and we do a million mods for a couple of problems. So, that's a little bit silly. But the way you can do it just is you go to index mod 2. Previous is you go to, you can just cache it, is my point. Right? And now things should be smooth again. And that's how you would do space optimization and all this stuff. Yeah, missed a spot. Yeah, let's give it a submit. Yeah, there you go. Fast time, low memory. It should be faster time because now you're not spending as much time on memory allocation, which adds up over time. I mean, you may not expect it because it is if you do it that way, it is the lower bound of like if you allocate n square space and your algorithm is n square, it is part of your lower bound, but it's the extra time, and you may kind of how do you say this? Yeah, I mean, and it just adds up, especially when you have n squares, you go to a million, at least on Leetcode. So yeah, I think I'm gonna end that here. I guess I should go with complexity, which we already kind of hint at. There is sorting here, but it gets dominated by clearly n square. So it's going to be n squared time. In space, this is linear. I mean, we talked about this. This is why we're here. This is why, I mean, the original one is n squared, but we worked our way down to O of n. So yeah, let me know what you think. This is how you do it. I kind of did enjoy exploring this problem a little bit because, I don't know, I just feel like I should have gotten this earlier, to be frank. But that's fine too. It was a fun learning thing. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good man, maybe I need to good mental health. I'll see y'all later and take care. Bye bye.